Okay, Bismillahirrahmanirrahim. Now, after we finish this exam, now we'll go to the written exam questions. As I said, just to complete the file. Yeah, consider this differential equation. What he wants the roots of the DC equation and the recurrence relation to the largest root of the DC in DC. Okay, so I have x equals 0. Very clear is regular singular point. Regular singular point. Right away, what's my solution? Y equal 0 to infinity Cn x to the power n plus r. So just, yeah. Also before that, let me find part A, which is the roots of the initial equation. I have capital P of x will be minus 1 over x. So small p of x will be x capital P of x. That is minus 1. And capital Q of x is minus 1 over x. Now before that, that means A0, the constant part, which is minus 1. Now Q of x is minus 1 over x also. So small q of x is x squared. Capital Q of x, that gives me minus x. So there is no constant coefficient. So B0 equals 0. So the initial equation would be what? R minus 1, A0, which is minus R, plus 0. So I have what? R squared minus 1 minus 2R equals 0. So I have R times R minus 2 equals 0. So I have 2 R's. R2 equal to. Okay. This is what I got. Very clear. Okay. Okay. Now what I will do, I will check now this is the initial equation. Now we'll go to so this is my initial roots. Got it. Okay, so B, going to find the recurrence relation. So let me continue with this. Xy double prime minus y prime minus y. That will be summation n equals 0 to infinity. This is y double prime, which is Cn n plus r minus 1 x to the power n plus r minus 1. It was minus 2 times x minus summation n equals 0 to infinity. This will be Cn n plus r x to the power n plus r minus 1. And y, it's just the Cn x to the power n plus r. Okay. Now, I can do two things at the same time. Take x to the power r from all, and I notice these two are the same. So I have x to the power r. I combine the first two, n equals 0 to infinity. Don't forget this is without x to the power r. Huh? So Cn n plus r minus 1 x to the power n minus 1 minus. Yeah, by the way, I can do this. Yeah, take Cn and n plus r common factor at the same time. So that will be n plus r minus 1 again, minus 1 x to the power n plus r minus 1 minus summation n equals 0 to infinity Cn x to the power n plus r. All of this times x to the power r. No r, sorry. This is n minus 1. I took x to the power r as a common factor. So this is, yeah, let me take more space. Minus summation n equals 0 to infinity Cn x to the power n. Okay. So I open the first one. This is negative power. This is 0. So I'll open the first power. X to the power r. I have what? To get the DC root, which should be the same. That will be C0 r times r minus 2, which is the same one. Which is the same equation. X to the power minus 1. I don't care about that. The rest n equal 1 now to infinity. Cn n plus r times n plus r minus 2 x to the power n minus 1 minus summation n equals 0 to infinity Cn x to the power n equals 0. Now we need to work out this. This is I will let k equal n minus 1. And this is I will let k equal n. So what I'm getting? I'm getting x to the power r. Let me write everything. C0 r minus 2x to the power minus 1 plus. Yeah, k equal n minus 1. So n equal k plus 1. So I have starting k equal 0 to infinity. What? Cn c k plus. I have n is k plus 1. Okay. So I have ck plus 1. Ck plus 1. Yeah, what about this one? K plus 1 plus r. K plus r plus 1. Okay. I have k plus 1 plus r minus 2. So it will be k plus r minus 1. Okay. X to the power k. Okay. And the rest minus summation k equals 0 to infinity ck x to the power k. That should equal to 0. So I have this relation. I can combine them. So I have what? Ck plus 1 times k plus r plus 1 times k plus r minus 1 minus 1 minus ck is equal to 0. So I have ck plus 1 will be what? 1 over this times ck. Okay, where k running from where to where k greater than or equal to 0. Good. Now R, he said, with which in this here wrote? Largest one, which was what? 2. Yeah. So R2 equal 2. So I have the relation ck plus 1 will be what? 1 over k plus 3, 2 minus 1, that will be times k plus 1, ck. Now, he wants what? 3, where is it? Find the recurrence relation. Oh, I got the recurrence relation. So that will be the recurrence relation. That will be the recurrence relation. Recurrence relation. Now, classify the singular point. Okay, so what is A2 of x? What are the singular point? X. This is what? X minus 3 times x plus 2. Yeah, minus 6 minus x. Yes. Then forget the square equal to 0. So I have x equals 0, 3 minus 2. Or let me make it minus 2, 0, 3. Better. Okay. So what is capital B of x? Let me find it here. Also, capital B of x will be x minus 3 over x times what? X minus 3 square, x plus 2 square. That will be what? 1 over x minus 3, x plus 2 square. Capital Q of x, that will be what? X times x plus 2 over x minus 3 square, x plus 2 square. That give me what? 1 over x minus 3 square, x plus 2. Okay, so I have the singular point, the factor, highest power, and denominator of p, highest power, and denominator of q, then the classification. Okay. So I have the first one, x equal minus 2. What will be the factor? X plus 2. What is highest power in the denominator of p? 2. Right away, this is irregular singular point. Okay. Actually, just for the information, this is 1 here, but that will not make a difference. Here is the problem, we should make it irregular. X equal 0, So I have x. Highest power in the denominator of b is what? 1. In q, 0. So that will be regular, satisfying the two conditions. X equal 3. I have x minus 3. Highest power here is 1, and here is 2. So this is regular singular. That's it. Okay, find the first non-zero terms of our series solution to the differential equation with respect to the largest root. Okay, I want to solve it, so let me do it. I have x equal 0. Is regular singular point, very clear. So my solution, summation Cn x to the power n plus r, 0 to infinity. Yeah, now let me, just to save space, let me start from here. So summation n equals 0 to infinity, Cn n plus r, n plus r minus 1, x to the power n plus r minus 1, minus summation n equals 0 to infinity, 2 Cn n plus r, okay, x to the power n plus r minus 1, plus summation n equals 0 to infinity, Cn x to the power n plus r, don't forget the 2, that should equal to 0. Here I multiply by 1, it should be x to the power n plus r minus 2, 1, make it x to the power n plus r minus 1. Here, just as is, as in the derivative, times 2 times minus 2, and this is plus 2. Okay. Now, what I will do, I notice these two are the same, so I can combine them. Actually, I can take what? Cn n plus summation n equals 0 to infinity. I can take Cn n plus r. Let me take x to the power r outside. X to the power r at the same time. Okay, to save time. That will be what? I have n plus r minus 1 minus 2. That times x to the power n plus no r anymore, n minus 1, okay, plus 2 plus summation 2Cn x to the power n, where n is starting from 0 to infinity. Okay, so I will start with the first one. That will be x to the power r. I have what? C0 n equals 0. That will be r. Here I have what? N plus r minus 3. So I have what? N, that will be r minus 3. R minus 3. Consider the largest, so with r equal 3. Okay. R minus 3, x to the power minus 1. Plus, this starting from 1. Cn n plus r, n plus r minus 3, x to the power n minus 1, plus summation n equals 0 to infinity, 2Cn x to the power n. Okay, so I'll do this trick about the k. Let k equal n minus 1 here. K equal n here. So what I have, this is will give me the initial equation. So I have C0, r times r minus 3 equals 0. This is the arbitrary, so I have r equals 0 or r equals 3. So the largest will be r equals 3, where I will use later. Okay, now this one, I have the summation. Let me go here. Summation of k equals 0 to infinity, because it will make nk plus 1. Okay, don't forget x to the power r outside. Okay, this is a get rid of it. You want to write it? I can write it. No need, but it's okay. X to the power minus 1 plus this one summation k equals 0 to infinity of what? C k plus 1 k plus r plus 1 times k plus r minus 2. Okay, x to the power k, and this will be k equals 0 to infinity 2ck x to the power k. So I can combine them. Let me do it at the same time. So I have ck plus 1 times k plus r plus 1 times k plus r minus 2 plus 2ck is equal to 0. So ck plus 1 will be what? Minus 2. I have ck here. Okay. I have the relation k plus r plus 1 k plus r minus 2. I have my largest r is 3, r2 or r1, okay. So ck plus 1 will be what? Minus 2 over k plus 4. And this is k plus 1. ck, where k greater than or equal to 0. And this is my relation. Now I will plug the numbers. K equal 1. C1 will be what? Let me write the formula. I need to go back and forth. Minus 2 over, is it? Yeah, minus 2 over. Let me rearrange it actually. ck, where k greater than 0. Now C1, k equals 0. So I have minus 2 over 2 times 5. C 0, correct? Yeah, I got k equals 0. Sorry. That is 1/4. I got k equals 0. That will be minus half C0. Now k equal 1. I have C2. That will be minus 2. This is 2, 5. C1. So it's minus 1 over 5 C1, which is 1 over 10 C0. K equal 2. He want how many 3 non-zero terms? First non-zero terms. Because it's written. So I'll take C3, then I will stop. Minus 3. K equal to, that will be 3 times 6. Okay. C2. That will be what? Minus 1 over 9, huh? Yeah, minus 1 over 9 C2. And that minus 1 over 90 C0. And continue. So it is a solution. Y will be summation n equals 0 to infinity Cn xn plus r 2 or 1, who cares what we call it. So I have x cubed outside, then I have summation n equals 0 to infinity Cn x to the power n. So that gives me x cubed times what? C0, C1x. That will be what? X cubed, C0. Oops. What is C1? Minus half C0x, C2, 1 over 10 C0x squared, 90 C0x cubed. That would be, take C0 outside. Half what? Half x cubed times what? 1 minus half x plus 1 over 10 x squared minus 1 over 90 x cubed, and so on. Also, you can write it as C0 x cubed minus half x to the power 4. This is my solution. Let me solve this. Where what you want me to do? Yeah, I want first to show that x0 is a regular singular point, and then find the roots of the indicial equation, and then find the recurrence relation. Yeah, which is not that difficult. No need to do the calculations, the full calculation. Okay, so to prove that x0 is a regular singular point, I'll find a2 of x. That will be 3x equals 0. So is a singular point. Now we just prove it's a singular point. How to prove it's regular? I have p of x, 2 over 3x, and capital Q of x minus 1 over 3x. So what's the highest power for x minus 0 in the denominator of B is 1 and denominator of Q is 1 also. So for sure, X equals 0 is a regular singular point. Yeah, and that's the first one. Now how to find the roots of the indicial, part B. Okay, let me, now I have capital B of X, capital Q of X. So I have small b of X, X capital B of X. That give me what? 2 over 3. So my A0 is 2 over 3. Small q of X will be X squared. Capital Q of X. That give me what? Minus 1 over 3x. So my B0 is 0. So the initial equation, yes, it's written here. Let me just put like this. Is R minus 1 plus A0 R plus B0. And that will be R minus 1 plus 2 over 3R. B0 is 0. And that will be what? R squared minus 1 over 3R. So multiply by 3. I have 3R squared minus R, which is R3R minus 1. So I have R equal 0 or R equal 1 over 3. You want me to find the recurrence relation with the larger indicial root, which is R equal 1 over 3 in this case. Okay, now I need to find the recurrence relation for this Cn. Okay, so I have Y, Cn x to the power n plus R, Y prime, Y double prime, sorry, that n. Okay, now multiply the first by 3x. So I have 3x y double prime. What is it? Plus 2 y prime minus y. That will be 3x times this. So I have summation 3cn n plus r minus 1 x to the power n plus r minus 1 plus summation 2 times y prime 2cn n plus r x to the power n plus r minus 1. This is summation. Don't forget this is starting from 0. Huh? Minus summation cnx n plus r. That should equal to 0. And notice these are the same. So I can combine them in one and take x to the power r common factor at the same time. N equals 0 to infinity. I can take Cn and n plus r as a common factor. What I have? 3 n plus r minus 1 plus 2 times x to the power n minus 1. Okay. Yeah, is it? Yes. I took n plus r as a common factor minus the rest, which is summation n equals 0 to infinity. Cn x to the power n, no need for r. Minus summation n equals 0 to infinity Cn x to the power n. Now I can open the first one. I don't need the indicial roots. I already did it, which is r times 3r minus 1. Also, you can be sure. So that gives me what? C0. I have r. When n equal 0, I have 3r minus 3 plus 2, which is 3r minus 1, which is the same. R times 3r minus 1. Good. Times x to the power minus 1 plus the rest. This is starting now from 1. Yeah, Cn n plus r times what? This is 3n plus 3r minus 3 plus 2. That is minus 1. Am I right? Yeah. You know what? Leave it because I think it's better to leave it. I will show you why later. That will be 3. Leave it as this. Plus 2. then minus, yeah, x to the power n minus 1 minus summation n equals 0 to infinity Cn x to the power n. Okay, now do this idea k equal n minus 1, and here k equal n. Here I'm getting the cancellation, or the initial equation, which is I know it. So let me work out these things. So I have k, don't forget x to the power r. So I have, this is make it equal to 0, so the rest should be equal to 0. So I have k equal 0 to infinity, but I have ck k plus r 3, because of that I told you leave it. I have n equal k plus r, k plus 1. So I have k plus 1, so I have k, is it? I have ck, n is k plus 1, so that will be, sorry, that will be k plus r plus 1. Since I make n k plus 1, no, k plus 1 plus r, this is 3. I have n plus r, so I have k plus 1 plus r minus 1, so that will be k plus r minus 2. Well, that I said, let us leave it. I have, close the bracket, yeah, x to the power k minus summation k equals 0 to infinity ck x to the power k equals 0. So I have now the relation, very clear. I have, no, this is ck plus 1, sorry. This is ck plus 1. I change everything, each n to k plus 1. So I have ck plus 1 will be ck 1. I have what here? K plus r plus 1 times 3 times k plus r minus 2. Okay. Now you wanted to choose what? R equal the largest, equal R10 and R2 equal 1 over 3. It's okay. So ck plus 1 will be what? 1 over, this is ck, this is 3. I have k plus 4 over 3. And here I have what? K minus 5 over 3. Yeah, correct. So I have what? Where k is greater than or equal to 0. Okay. So I have 1 over, yeah, I can leave it like this, or I can simplify it, which is what? 3k plus 4. And this is have what? 3k minus 5. And this is 3. And that should be 3. Since it's over 3, then I take it to the numerator, where k is greater than or equal to 0. So this is this is k plus 1. Yeah. This would be my recurrence relation. Okay. Let me do one more. Find the first non-zero terms. Okay. Non-zero term, this series solution. And corresponding to the larger in this. You want to find the 3 non-zero terms. So I need to go more. Okay. Let me do the quick. This, yeah. This is the regular singular point. So I have y. Just let me do it quickly. Cn x to the power n plus r. Plug it into the equation. That give me what? Summation n equals 0 to infinity 2 Cn n plus r minus 1 x to the power n plus r minus 1, not 2, multiplying by x. This is minus summation n equals 0 to infinity. That is what? Cn n plus r x to the power n plus r minus 1 plus 2 Cn x to the power n plus r. That is equal to 0. I can combine these two. So I have, and take x to the power r is common at the same time. So I have summation n equals 0 to infinity. What is that? I can take Cn n plus r, we did it before. I have 2 n plus r minus 1 minus 1. Is it? Yeah. 2 n plus r minus 1 minus 1 times x to the power n minus 1 plus summation 2cn x to the power n, where n starting from 0 to infinity. Well, in the first one to get the indicial equation. So we have what? C0 r. This is what? N equals 0. I have 2r minus 2 minus 1, so it's minus 3 x to the power minus 1 plus this is starting from 1. Let me write, squeeze it here. M plus r. This is what? 2 n plus r minus 1 minus 1 x to the power n minus 1. This is starting from 0. Don't forget the 2 x to the power n. That equal to 0. So from here, I'm getting the indicial roots r equals 0 and r equals 3 over 2. What you want? You want the larger. So this is, I'll take this. Now I'll continue with this one. So I have summation x to the power r's. Yeah, I'll do this k equal n minus 1 here and k equal n here. So n equal k plus 1. Don't forget that. Then I have summation k equals 0 to infinity. Ck k plus r plus 1. Here I need what? 2 times what? N is k plus 1, so that would be k plus r minus 1. X to the power k plus summation and k equals 0 to infinity 2ck x to the power k. Yeah, so that will equal to what? That equal to 0. So I have now the relation. I can combine these two, actually the same power, the same starting point. So I have c, this is k plus 1. What is this? This is ck plus 1. Oops. So I have ck plus 1 equal minus 2 ck. What I have here, k plus r plus 1. And I have 2k plus 2r minus 1. Okay. Where k greater than or equal to 0. So I have r, we said r is what? 3 over 2. So let me see what will happen. Say k plus 1 will be minus 2 over what? K plus r plus 1. That is what? K plus 5 over 2. And here I have what? 2k plus 2r. So I have 2k plus 2. Yeah, 3 minus 1 is 2. So I can take 2 common factor. I have minus 2 over, don't forget the ck, minus 2. I have 2 common factor. Multiply it here. I have 2k plus 5 times k plus 1. C, this is C. ck, where k greater than or equal to 0. So this is what I have as a relation. Ck plus 1 is minus 2 over what? 2k plus 5 times k plus 1 ck. Well, k is greater than or equal to 0. So yeah, I do the same one. K equal 0. I have C1 is minus 2 over 5 times 1. C0. K equal 1. I have C2 will be minus 2 over 7 times 2. C1 minus 1 over 7 C1, which is 2 over 35 C0. I need only 3 terms. That's what I need. You need the first 3 non-zero terms. So y will be equal summation cn x to the power n plus r 2 I choose R2, not R1, the largest one. So I can take x to the power 3 over 2 common factor, and they have C0. And that will be x to the power 3 over 2. C0, what is C1? Minus 2 over 5 C0x, and that 2 over 35 C0x squared, and so on. I can take C0 common factor. I have 1 minus 2 over 5x. Yeah, I think it's very clear. That will be by 2 of x. That will be the solution. You can check the answers. Maybe there's some calculation, but that's I think that's enough for this video. But we did many examples related to that. So let me stop the recording. Yeah, thank you.